Hello and welcome to the Unit 2 Lesson 3 tutorial. This is going to be about parallel and perpendicular lines. So first off, we got to, of course, define these words. Parallel lines are lines that lie in the same plane and do not intersect. Basically, you have train tracks. And so the lines the metal poles that go on train tracks, those are parallel lines. They never intersect each other. They never cross one another. And then perpendicular lines are lines that intersect at right angles. So let me just go ahead and demonstrate to you with some pictures. Our first picture is going to be parallel lines. So there you have it. And our second picture is perpendicular lines, or lines that cross at right angles. Then another word that I want to give you guys, which I know that you will probably already know this, but is slope. And slope basically tells you how steep a line is, how high it goes, how far it goes. And the equation for finding a slope is basically going to be rise over run. I'm going to show you what I mean by that. Basically, what you're going to figure out is the rise is how high your line goes. So if I have a line here, I'm going to figure out how high it goes and then how far it goes. Oops. Pretend like that's a straight line. So how high it goes and how far it goes. And that will determine the slope. Now the equation for slope is going to be a nice easy equation. We're going to be using coordinates in order to do that. So our coordinates are going to be like we always do whenever we're doing kind of a generic equation, is going to be x1 and y1. And our other coordinate is going to be x2 and y2. And with these, we're going to do the rise divided by the run. So we're going to take the difference of the rise divided by the difference in the run. So our y is what we rise. So I'm going to write the word rise above the y just so I can remember that. And I'm going to take y1 minus y2. That's going to be our rise. And then our run is our x. So I'm going to take our x1 minus our x2. And that will give us how far we run, or how far we go with our coordinates. So let me demonstrate this with a problem. Here I'm going to find the slope of a segment AB if A is at 5, negative 3, and B is at 2, 3. I'm going to use this equation to be able to find my slope. Let me go ahead and just say that this equals slope. So I'm going to plug in my y1 and y2. So I'm going to go ahead and label these. I'll label this in a different color. This is my y1 and my x1. And this is going to be my x2 and my y2. So now all I have to do is plug the numbers into my equation. So my y1 is negative 3 minus 3. So I have negative 3 minus 3. That's a 3. 3 was my y2. Divided by my run. So I'm going to do my x's now. I'm going to take my x1, which is 5, minus 2. From here, I just simplify. Negative 3 and negative 3 is negative 6. I can call this plus negative 3 if you wanted to. And then we have 5 minus 2, which is 3. Divide that all together, and my final slope is going to be negative 2 over 1, or negative 2 would be fine. And that's how you find your slope.